So, in our last video, we talked about all the different places NASA has been looking to send humans next. And while there are plenty of fascinating moons and other rocky worlds out there that are worth exploring, let's not forget about the moon, Earth's closest rocky neighbor and the ultimate frontier for humanity. There's so much more left to learn about it, and so many reasons why the moon is an amazing place for us to test our mettle at being multiplanetary. And while the surface of the moon might seem desolate and lifeless, researchers have found evidence of volatile organic compounds there. Volatile organic compounds, or VOCs, are molecules that contain carbon-hydrogen bonds and can easily transition between solid, liquid, and gas forms. We find them everywhere here on Earth, and scientists think they could be key to understanding how life began on our planet and potentially elsewhere in the universe. There are over 900 known VOCs, and they play important roles in many of Earth's processes. They're crucial components of our atmosphere and oceans. They help regulate our climate and weather patterns, and they form the basis of many kinds of life-sustaining chemical reactions. On Earth, VOCs are released into the atmosphere through both natural processes, like volcanic eruptions, or decaying vegetation and human activities, such as the burning of fossil fuels. Once in the atmosphere, these compounds react with each other and with tiny particles suspended in the air to form something called particulate matter. This is a major component of smog and is considered by the World Health Organization to be one of the most significant threats to human health, with over 4 million deaths every year attributed to outdoor particulate pollution. Because VOCs are so important to life as we know it, scientists are keen to learn whether they can be found on other worlds too. But here on Earth, VOCs are pretty reactive and tend to hang around for only a few days before breaking down. That makes them hard to detect on planets like Mars, where the atmosphere is thin and the atmospheric pressure is low. Finding VOCs on the moon, however, could be a game changer because even though the moon has no atmosphere to speak of, it does still have some volatile organic compounds frozen on its surface. The moon formed about 4.5 billion years ago from the debris of a giant collision between Earth and a Mars-sized planet named Theia. Most of the moon's building blocks were heavier elements like oxygen, silicon, and magnesium, but some lighter elements managed to work their way into the mix too, including hydrogen and carbon, which combined to form methane and other Scientists think that over billions of years, the sun's radiation and the solar wind may have caused some of these light elements to break free from the lunar surface and escape into space. So today, the moon has a very thin exosphere that's almost entirely hydrogen, with traces of other gases like helium and neon. That means the moon isn't the dry, dead world that it's often made out to be. In fact, researchers now believe that the moon could still be outgassing volatile compounds, releasing them from its interior to its surface. Evidence of this comes from spacecraft like NASA's LC-ROSS, which orbited the moon from 2009 to 2018 and analyzed the composition of the thin layer of regolith dust that covers the lunar surface. Using a particle accelerator, LC-ROSS shot a beam of ions at the regolith to see what kind of dust was kicked up. The results revealed the presence of several VOCs, including methane, ethane, and propane. These discoveries were actually somewhat surprising, because the moon's surface is exposed to the harsh environment of outer space. It is bombarded by cosmic rays and solar winds, and temperatures range from 100 degrees Celsius during the day to negative 173 degrees Celsius at night, so any VOCs on the surface should be broken down by now. The presence of these hydrocarbons suggests that they are continually being replenished from deep within the moon. What's more, the distribution of these VOCs across the moon's surface is uneven. According to LC-ROSS data, they tend to cluster near the moon's south pole, where temperatures are consistently cooler, and that gives scientists clues about where to look for even more VOCs. Because of the uneven distribution of these compounds, researchers believe that the best place to find VOCs on the moon is permanently shadowed regions, or PSS. These are areas near the poles where the terrain is so deep that sunlight never reaches it. In these perpetually dark places, the temperature never rises above negative 150 degrees Celsius. And since VOCs are solids at those temperatures, they don't evaporate. As a result, researchers predict that these areas could contain the highest concentrations of VOCs on the moon, making them potential treasure troves of organic material. It's possible that these compounds have been gathering in PSRs since the moon formed, protected from the harsh environment of space. And if that's true, then they could preserve evidence of what life on early Earth might have been like. Studying Vox in these cold, dark places could also tell us more about the moon's interior. We already know quite a lot about the lunar interior thanks to NASA's mission to the moon in the 1960s and 70s. In fact, we know that the moon has a core, a mantle, and a crust that are all remarkably similar to Earth's own. What we don't know is how these layers interact with each other. The moon's magnetic field, for example, is generated deep within its core, but we're not sure how that happens exactly. Understanding the moon's internal structure could help us understand not just the moon, but the entire solar system. In the early days of the solar system, Earth and the moon were hot, molten worlds, and if we could figure out what was happening inside them back then, we would learn more about how planets form and evolve. Studying VOCS could also help us determine whether or not the moon is still volcanically active. If it is, then it could mean that we'll need to take extra precautions when setting up future moon bases. Right now, NASA is developing plans for the first of the Artemis missions, which will land astronauts on the moon in 2024, and one of those plans involves creating a base camp near the lunar South Pole. This base will support scientific research and exploration of the surrounding area. But if there are still active volcanoes nearby, that could put our explorers in danger. The good news is that there's a relatively high concentration of VOCS near the lunar South Pole, so they could be a good indicator of volcanic activity. VOCS could even be a sign of geothermal energy. After all, we have seen evidence of this in places like Yellowstone National Park, where the presence of geothermal features like geysers and hot springs is linked to the release of VOCS, like methane and ethane. So the same thing could be happening beneath the moon's surface. If we find evidence of geothermal activity, then it would be a great boon to any future settlements on the moon. Geothermal energy could be harnessed to power homes, labs, and other infrastructure, and it could also provide the water that future colonists will need to survive. That's because water vapor is another volatile organic compound, and scientists think that the moon could be hiding huge reserves of it beneath the surface. Water on the moon was once thought to be rare. That was until the Ross orbiter detected water molecules in the lunar dust. Since then, several other spacecraft have confirmed the presence of water on the moon, including India's Chandrayaan-1, which discovered water molecules at the top of the lunar exhaust. It's unclear how much water is present on the moon, but it could be more than all of the water on Earth. According to one estimate, the lunar crust could contain about 2 meters of water for every square kilometer of surface area. And most of that water could be found in the polar regions, where temperatures are the coldest and where VOCS tend to gather. Water could be released from the moon's interior through a process called deliquescence, which is similar to evaporation. Deliquescent materials literally suck up water from the vacuum of space. So if VOCS are being released from the moon's interior, then water could be coming along for the ride. This could explain why the Ross orbiter saw higher levels of hydrogen at the moon's poles. Hydrogen atoms are, of course, the building blocks of water, and if they're being released from the moon's interior, then water itself could also be seeping out. Now, all of this is just speculation based on what we've observed so far. There is still so much we don't know about the chemistry of the moon and how it interacts with space. That's why it's so exciting. When we return to the moon, this time to stay, we'll be equipped with new instruments to study the lunar surface and investigate the origins of the solar system. Understanding the moon better will teach us more about the Earth too, and the delicate balance of compounds that make life on our planet possible. It'll also help us prepare for further adventures among the stars and give us a better chance of succeeding there. Thanks for watching this video. I hope you learned something new. If you want to watch more videos like this one, just hit the subscribe button.